We're going to talk about where noise comes from. I've included a bunch of different traces on this slide. I'd like you to pause the video and decide which ones you would call noisy. Okay, now that you've made your picks, I have to inform you that when we use the word noise in this class, we're referring to a very specific kind of purely random behavior. There are lots of signals that can make oscilloscope traces look bad that aren't purely random. So there are very few traces on this slide that exhibit noise as we define it. The large spikes in this trace are caused by a switching power supply. The power supply doesn't seem correlated with the sine wave on the screen, but its behavior isn't random. It's actually periodic, and you might be able to pick out the switching frequency from this trace. These second two traces are showing the output of unstable amplifiers. The amplifiers create large, high-frequency sinusoids, but these are quite predictable. They only occur at one frequency. This third trace is 60 Hz pickup in a circuit, which is sometimes called hum by the audio amplifier community. 60 Hz is the frequency of American wall power, and it's very easy to make an accidental antenna in your circuit, such that you get a 60 Hz signal somewhere inside of it. Pickup generally refers to signals that show up on these accidental antennas, and 60 Hz pickup is just the most common kind. Only this final signal qualifies as noise in this class. These are random fluctuations, which are often small, caused by two sources of noise called thermal and quantization noise. Thermal noise and quantization noise are the two sources of noise that I mentioned on the last slide, and they're the only two noise sources that we're going to consider in this class. Thermal noise comes from random motions of electrons in a resistor. If they all happen to move in the same direction, then we get a current. And that current interacts with resistance by creating a small noise voltage. This is sometimes called Johnson noise after one of the early derivations of its existence. Quantization noise comes from rounding errors when we turn analog signals into digital ones. For example, the voltage we're applying to the analog to digital transfer function on the right could get rounded up or rounded down, and either way the number we pick to represent the voltage will be pretty far from the actual value, which would be indicated by like a straight line running through this stair step. We'll be diving into greater detail on these noise sources in the next few videos. So in summary, strictly defined, noise is purely random. Pickup, instability, switching transients, and hum are not noise, as far as we're concerned, and there are circuit techniques to reduce all of those, but they're not what we're talking about here. Thermal noise comes from random fluctuations of electrons in resistors because they're hot and rattling around. Quantization noise comes from rounding errors in analog to digital converters.